Hey everybody, it's Miss Dietrich. We're going to take a look at these two different examples to help us understand a little bit about what it means to reflect something over or across the y-axis and what it means to reflect something over the x-axis. So if we look at this red triangle and this blue triangle, do you see how in the example here, this is the original triangle, the blue one. The reason that we know that this is a reflection is because they put the little apostrophes after the letter, which means it's the image reflected. Now, if we think, what's the ordered pair for point A? The ordered pair for point A is a 3, 3. Now, if we take point A, its reflection, here's the ordered pair right here. It's a -3, 3. Now, what we should be asking ourselves is, notice that we're reflecting over the y-axis, and notice that the y-axis coordinate, which is the second one in the ordered pair, stays the same. So what do we notice here is we notice that the x coordinates are opposites. So that's always going to be true anytime you're reflecting over the y-axis. You're going to make the x term its opposite. So if we take a look at point B, the original point is 5, 6. What's the opposite of 5? Well, it's a -5. So notice that the y coordinates stay the same and the x coordinates are opposites. And likewise with point C. If we take a look at point C here, the ordered pair for that is a 7, 3. We're going to keep the x terms the same, and we're going to change the y terms, or I'm sorry, the x terms to their opposites. So what's the opposite of a 7? It would be a -7. All right, so that's reflecting over the y-axis. What if we're reflecting over the x-axis? So in that case, we have our original triangle right here, which is the blue triangle. And when we're reflecting over the x-axis, that means it's going to be on the other side of the x line, which I just highlighted. The x line has to be on the other side. So if it's going to be reflected over the y-axis, just to go back to this one for a moment, that means that the triangle will be on the other side of the y line. So these are mirror images of each other. So let's take a look at the original point for point A. Point A is a 3, 3. Its reflection is a 3, -3. So notice that in this case, we keep the x coordinates the same, and it's the y coordinates that we change to its opposite. So the y was a 3, the opposite of that is a -3. The same thing would be true for point B. Point B, notice that the x coordinates are the same. It's the y coordinates that have been changed to their opposite. The opposite of a 6 is a -6. And point C, if we take a look, the x coordinates are the same. It's the y coordinate that has been changed to its opposite. What's the opposite of a 3? Well, it would be a -3. All right, so how do they show that up here? What does this thing mean up here? It means that if you, whatever your x and your y is, you change the y to its opposite. That's what that negative symbol means in front of the y. If we go back and think about what this means, whatever your x and y coordinates are, you change, in this case, the x term to its opposite. So that's what that negative symbol means in front of the x. It means the opposite of x. So this can be helpful in a lot of situations. Let's just do some simple reflections with not two-dimensional figures, but how about just one point? So let's take a look at, let's plot something. How about we plot over 3 up about 4? All right, so we'll call that point A. Point A, the ordered pair for that is a 3 and a 4. So if we're going to reflect that over, how about the y-axis, that means we're going to put on the other side of this yellow line because the yellow line is the y-axis. Now, remember that it's going to be the same distance from the y line, only it'll be on the other side. So if we think about putting that on the other side, that means the reflected point will be here, and we'll put an apostrophe. All right, so what's the point for this? What's the ordered pair of the reflection of point A? Now, if we think, what's the ordered pair? We're going to the left 3, but we're still at the 4 on the y. So again, notice that the x coordinate is opposite, the y coordinate is the same. Now, if we're going to take that same point, and instead of reflecting it over the y-axis, now let's look to see what would happen if we reflected that instead over the x-axis. So let's take that original point, that green point, point A. And now let's reflect it over the x-axis. Now remember this yellow line right here, that's the x-axis. So that means it's going to be on the other side of that line. So we'll erase reflecting over the y. And now let's think about reflecting over the x-axis. What would the ordered pair be? All right, so same story there. We want to keep that same distance. So if this is 1, 2, 3, 4 units away, it'll be 4 units away on the other side. All right, so 4 units away, that's going to put us at, we're still going to be over 3, but this time we're going to be down 4. So our new ordered pair is a 3, comma, -4. Now notice that when we think about our x and our y-axis, the x-axis stayed the same, and it was the y-coordinate that was changed to its opposite. All right, so that's just a quick crash course on reflections. Hopefully you found this helpful.